Welcome to day 2 of the Blockchain Application Stanford Summit. Again, want to thank Kuhn for Kuhn is the brains behind all of this. It was his idea, and it's been an amazing day 1. So thank you, Kuhn, and Stephen and myself. The 3 of us also run the Stanford Blockchain Accelerator. Teach a course as well, and we're partners in the Blockchain Builders Fund. Also want to thank the Stanford Blockchain Club for working on this with us, Jay, Sophie, and Bridget, and of course Aaron, who's up there with Iron Mill, who's one of the teams in the Accelerator, handling all our AV goods, and Ricky and Trudy, who've been awesome, and the entire team. So, sweet. We've got an awesome lineup today. We're starting the morning with everything zero knowledge. So this is going to be super exciting. And with that, we're going to get started with Ben Livshits from ZKSync.
Can you hear me? Yeah? Okay. Super. Look, it's great to be here and it's great to be back. So I was a PhD student just right across the street from here in the computer science department some years ago. So always nice to make it back to Stanford. So just a couple of words about myself. These days I'm a professor at Imperial College London, but the majority of the time I spent on ZKSync, working on ZKSync, Meta Labs. That's where most of my focus is these days, and that's actually going to be the focus of today's presentation as well. So we have a couple of papers at the main conference. If you're interested in the kind of work we do in the intersection of programming languages and system security, please go and listen to that. There are some PhD students who will talk about that. But the last 4 or 5 years, I've been focusing quite heavily on blockchain, topics related to DeFi, and these days increasingly rollups. So what's the TLDR for this presentation? Well, roughly speaking, in the rollup space, we are, as a community, looking at a huge number of options, and there's a lot of complexity to many of these designs, and I'll go through some of the examples in the next several minutes as well. And I think we sort of still have more questions than we have answers, and my perception is that we don't, as a community, have very clear sort of outcomes the way, let's say, the Ethereum community has at this point after many years of going through designs and rejecting many of them and arriving something that's actually sort of working for a large number of users. So the way I want to sort of approach it is that, I mean, first of all, let's just kind of, look at where we are in the sort of crypto market, if you will. And I think certain things sort of come out as a result of that. And so there's quite a lot of consolidation of strength. And by that, I mean user numbers, user growth, things of that sort, as well as the sheer number of developers who are developing on the Ethereum platform. And that's kind of what happened in prior bear markets as well. So we see quite a lot of consolidation around some of these bigger platforms, right? So that's not utterly surprising, is it? And so in some ways, it's actually a win for Ethereum. It's in part due to the focus on openness, open standards, open community participation, things of that sort. And so that's quite wonderful to see. On the other hand, so that when it comes to development and execution, we see quite a lot of consolidation around the EVM. And let me be the first one to tell you that the EVM is not necessarily God's gift to humanity. There are many challenges with that virtual machine, but at the same time, that's also what sometimes tends to happen, right? Some of these languages, some of these kind of programmability designs, despite their shortcomings, still tend to stick just because of the sheer number of developers who've learned it over the last 5 or 6 years. And this is why we have chains other than Ethereum sort of migrating closer to EVM designs. And that's where there's quite a lot of energy compared to potentially better designed languages and better designed runtimes. Although there are some interesting things that happen on the intersection. We heard a talk yesterday about how to combine sort of the best parts of the EVM and things like WASM. I think that's also quite exciting. Now, Ethereum is quite explicit about its scaling plans, right? It's sort of roll-ups all the way, right? So Ethereum's plan is, to simplify is to basically be settlement chain, and then it's up to these roll-ups to figure out what to do in terms of execution. The majority of focus when it comes to execution is on speed up, scale up, whatever you want to call it, although there are some notable exceptions to that. So there are things like AdStack, where the focus is primarily on privacy, and that's really their main claim to fame. But for the most part, for the rest of the talk, I'll talk about speed, scale, things of that nature. So if you were here yesterday, I'm sure you've seen this, you've heard this somewhere else, perhaps. So there are optimistic rollups. So we heard from Arbitrum yesterday, and zero-knowledge rollups such as ourselves, ZKSync, but also others like Scroll and Polygon and Starkware, and I think there'll be talk from Starkware in the afternoon as well. And these are increasingly becoming platforms of sort, right? So we talk about the modularity thesis yesterday with data availability solutions such as Celestia and EigenLayer. I think there's a talk in the afternoon about EigenLayer as well. And I think that's all good and well, but at the same time, I think we also need to think about sort of more vertical integration. So specifically, I think in this space, people talk about sort of the end user, by which they mean like, a sole person, like a consumer, so to speak, with a wallet. And I think that's great, but I think that's not the only use case. So increasingly, we're starting to think about stacks. In ZKSync, we have what we call ZK Stack, right? And so that gives users, as well as companies, enterprises, that sort of thing, organizations, the ability to create vertically integrated solutions with the kinds of properties that they're comfortable with. So we'll talk about things like fee structures, fee markets, and I think these kind of design decisions are quite different depending on whether you look at the sort of consumer end, sort of the Ethereum default, if you will, as opposed to the sort of this more enterprise setting that I think will become quite popular as well in coming years. Some numbers for you. This is from a website called L2Beat, and so these numbers are, well, fairly a bit, right? So basically, if you look at the last year of activity, from August last year to August this year, this is a screenshot from yesterday, there's a significant amount of growth, right? So basically scaling factors like how much is getting settled on rollups compared to mainnet on the kind of top graph here, but you see basically progressive growth, right? Compared to mainnet, which is mainnet transactional activity. So you can sort of see this line towards the bottom shown in blue. There's more and more sort of that's kind of happening on rollups, sort of collectively speaking, right, without separating which ones are doing better than others. And then TVL, the value locked at the bottom, sort of that's growing as well, right? So we can sort of probably debate how good a metric TVL is, and I think there are many people who do so, who challenge that kind of measurement approach, but at the same time, it's fairly clear there's just more going on. Now, I think a slightly more subtle question is like, what is this due to, right? Like, what's actually driving this? And perhaps a slightly sort of controversial observation is that if we didn't have a significant portion of DeFi wanting to migrate to rollups, we probably wouldn't have these outcomes. By which I mean that, a strong driving force is still sort of EVM-based as opposed to sort of driven by something else. So, like, personally, I would love to see different workloads kind of dominating, if you will, or driving this space, but I don't think we're quite there yet. So, for instance, there are some really interesting proposals, as well as work from companies like RISC-0, which allows you to basically run RISC-V executables, which, if you think about it, would allow you to do things like decentralized on-chain gaming, right? Which sounds, on the surface of it, as a very attractive kind of workload, but we don't quite see it there yet. So I really hope that that will materialize, but it will probably take a while. So the majority of this, I would imagine, is sort of driven by some semblance of DeFi migrating over. So I wanted to look at sort of multiple dimensions when it comes to rollups, and here's a list. We'll talk about sort of these things in order, and so depending on how much time I have, we'll spend, hopefully we'll not run out, essentially. I want to get to the end of this, which is like integrity and privacy. So decentralization, right? So, I mean, if you're cynical about it, so currently there's very little decentralization to most of these rollups. At the same time, the TVL numbers up, so like what gives? Like, you know, do people really care? And if they cared about decentralization so much, why are they willing to basically engage with the current generation of rollups? So, look, I mean, sort of pragmatically speaking, there is nothing wrong with the path of, progressive decentralization, right? So start in a way that's centralized and then figure out how to move different parts of your stack to a more decentralized setting. And I think, you know, what's less clear perhaps is that like how do you basically retain the advantages of rollups, right? If you're moving to a rollup like ZKSync for its speed as well as cost, like how do you retain the benefits of speed and cost, low fees, if you want to become more and more decentralized? Like, you know, how do you basically make this work at the same time? And so the other thing is that decentralization is a multidimensional concept, right? So it comes in multiple guises, multiple forms. So, and which one do we sort of care about, right? So there are things like node ownership, which is related intricately to censorship resistance. Things like data center diversity, not everything should run in like the AWS, let's say. Geodistribution, which has to do with latency, with speeding things up. And so in a sense, like how much decentralization is good enough? And like what's the use case that's driving this? And so remember I talked about, you know, the sort of the wide open case, so to speak, the end consumer case, as opposed to like maybe an enterprise case. And I think answers will be sort of different for those two cases as well. But if we go and look at Ethereum, I mean, sort of matching that level of decentralization, I think will prove to be quite a challenge, right? So this is the number of nodes, which is over the last 6 months, which has grown, even in the last 6 months, it's grown really quite significantly from about 550K to about 900K, right? So that's just like the sheer number of validators. Well, do we need that or do we not need that? And like, what's good enough in a sense, right? So that's sort of, you know, a relatively simplistic way to look at decentralization. Probably not the only way. So there's this thing called Project Sunshine, eastsunshine.com, and so this looks at multiple dimensions of decentralization, and this is a little bit more subtle, isn't it? So they look at things like consensus client diversity, they look at execution client diversity, the number of clients, right, things of that sort, and then towards the bottom there's geolocation diversity, so how many, you know, places and continents are represented, and what is it, like how easy is it to basically suffer a network partition, that sort of thing. I guess they're trying to approximate sort of ownership pool, ownership diversity by looking at things like staking pool decomposition, things of that sort. And so is this like what we sort of need to mimic in the rollup space, or is it too much trouble? And perhaps the answer is that maybe this is too much, especially because we can rely on the underlying L1 for censorship-resistant purposes in sort of the worst case. But this gives you a bit of a counterpoint when there are people who sort of, you know, say that we should basically bravely march down the road of decentralization for rollups. You know, the question is like, what's good enough? So kind of another way to look at it is that, you know, what about sort of the opposite side of this, right? I mean, if you want to basically build high availability systems, and again, this is especially important in these more enterprise-related contexts that I was alluding to before. So is there anything in this space that's starting to approach 5 nines of availability, or is that not really the case? And if this is something that we want to have as an outcome for our sequencer network, for our proven network, let's say, like how do we get there? Right, and is the same path of decentralization that Ethereum mainnet followed, is that the right way to get there in the first place? Here's another sort of related question, right? So a lot of these discussions imply, if you will, permissionless participation. Is that a necessary thing? Is that really absolutely necessary? And is that kind of the end goal for these kinds of systems? It's actually not obvious, right? There was a talk from Arbitrum, I think, last year that basically about sort of a sequencer strategy that basically I think left it at a point where we actually would still have effectively permission participation, the ability to slash stakes and do things of that sort, so that creating a new node is not a free activity necessarily. And there are some academic papers like the one I'm mentioning at the bottom that basically take a much more detailed look at the amount of decentralization, both in the Ethereum ecosystem as well as the Bitcoin ecosystem. So sequencers, there is a lot of focus on sequencers in this space, isn't there? So there's a talk, in fact, at the consensus workshop that will be happening here in the afternoon in another building. So, I don't know, somewhat cynically speaking, maybe there's a bit too much focus on sequencers and sequencer decentralization. Feels like a bunch of people are trying to enter a restaurant and they're sort of stuck at the entrance here a little bit. So, and the thing is that that's like not the only sort of dimension that there is to decentralization either. And so I feel like, you know, we've been sort of borrowing a little bit too much, perhaps, from the consensus literature. I mean, maybe that's a good thing, maybe not so much. We heard about variants of the hot stuff approach as well as DAG-based consensus approaches, and there are people sort of who are proposing variants of that. So Espresso is proposing a shared sequencer design that basically follows in the footstep of these consensus approaches. But again, as I kind of alluded to before, it's not entirely obvious to me that sequencers should be like following, you know, the same formula, that is to say, fully permissionless POS kind of design. It's also not clear to me that there cannot be like a more custom design that focuses not on state machine replication, but on sequencing as a separate kind of aim, as a separate goal that might actually provide some better properties in terms of, let's say, latency that would be significantly less than a second, you know, things of that sort. And again, you know, you can sort of ask the same questions of these kinds of designs as well, which is like, you know, how big of a network do we need, right? I mean, so, you know, let's say Cosmos, right, if we talk about Tendermint, so something like 50 to 100 nodes maybe is good enough, but is that, like, how do we get that number and what number is sufficient? So suppose I have, I don't know, 10. Do I know that that's not sufficient? Suppose these 10 nodes are highly connected with low latency links, and suppose they are properly partitioned across multiple data centers. Is that not good enough? And in what sense is that not good enough if I still have sort of censorship resistance as well as the ability to force transactions through the L1 as my kind of solution of last resort? So it's also not obvious. I mean, I think there are multiple designs that we've seen out there in terms of integration or possible integrations between data availability solutions as well as sequencer solutions. I think there are sort of multiple ways to sort of connect these kinds of networks. There are multiple ways to look at decentralization properties of all of them. And in some sense, again, if you sort of basically take the modular thesis, I think it's really quite attractive, but how to actually make it together end to end in a way that's robust and affordable is actually quite non-obvious to my mind. So for example, like if you have multiple tokens at play and they basically, you know, there could be volatility with these tokens, let's say. So how do you reason as an end user? How do you reason about the cost of actually doing compute, right? Like sending transactions as well as execution. So it becomes a highly non-obvious problem. And again, if you really care about your end-to-end outcomes, how much modularity you can afford, I think is a bit of a hard question, despite the fact that in principle, I am quite open to these possibilities. When it comes to, you know, sequencers and MEV, there is, you know, I mean, clearly there are at least two relatively extreme viewpoints, one of which is like, let's try to prevent MEV at all costs, right? And so there are different designs, commit reveal schemes, sort of fairness-focused consensus approaches from, let's say, Cornell Tech. There's a number of papers about that, private mempools, things of that sort. And then, you know, the question is like, how far are you willing to go and what are you willing to spend to basically fight MEV? And is it all forms of MEV that you're willing to fight rather? Because like arbitrage is a form of MEV as well, and so maybe it's good to have arbitrage so you don't really have deviations in terms of prices on mainnet versus one rollup versus another rollup. But like, are you basically going to throw away the baby with the bathwater if you kind of go too far on the left here? And the other side of this is that like, let's just embrace all the MEV that's possible, and you know, basically it can, as I said, play a relatively positive role in the ecosystem. And you know, clearly we can just do PBS or ePBS. And basically, you know, embrace relayers like flashbots and effectively repeat the same formula that we've seen on Ethereum's mainnet. And I think, look, for the open case, perhaps that's actually not such a bad answer. And basically then the rollup, the L2 becomes just an accelerator function, right? But if we are talking about L3, so we call them hyperchain, then I think it becomes quite a lot more debate about that. If I want to have an enterprise, a bank, what have you, running an L3, like do they want to be subject to MEV of parties that they have never encountered, right? And they can have competitors extracting their MEV, that sort of thing, and perhaps that's not such a great outcome. So my sense is that there needs to be some sort of bifurcation when it comes to MEV-based outcomes. And again, there is a ton of complexity. There is a number of interesting proposals with a sort of, for example, Aztec guys ran an RFP process a few months before this, and there's a number of proposals with names like B52 that focus on basically burning the MEV that could be extracted and giving it to the prover network. I think some of this is actually potentially quite exciting. But again, we sort of don't know what the right answers are, I would say, given that we haven't really deployed these systems. So shifting my attention to provers a little bit here. So again, a lot of focus in sequencers, not actually quite enough focus on provers as far as I'm concerned. So we've seen, a number of proposals from, say, the Neal Foundation, Banzai, from Zero, but I think there's just a lot more complexity that we haven't quite encountered. We're sort of taking it left to right, if you will. So from the way, transactions enter the rollup, right? And we don't quite know how to deal with provers. And I think there's any number of really complex problems there. So like we sort of need to have designs that focus on ultimately the end-to-end speed of proof production, as well as reducing hardware requirements and increasing the parallelism, as well as distributed proof generation. And I think like what the right mix of these properties is, we don't quite know. Right, we're still we're sort of discovering some of that. So, for example, at ZKSync, we released a new proof system called Bootjoom that significantly reduces the memory requirement to so that basically these smaller provers mean that they can be run by laptops, let's say. So, but again, the fact that you can run something on a laptop doesn't mean that you'll be the winning prover, right? So it kind of goes back to the idea of proof markets and how to orchestrate those, so you basically have sufficient prover diversity. So kind of focusing a little bit more on the hardware side. So like on the one hand, we basically have a lot of progress on the proof system side. So new proof systems have been announced, like several of them in the last months alone, in the last couple of months alone. And I think, basically this space shows no signs of stopping, right? So there are experimental projects like Nova Supernova, Sangria. There is something that's, there are some interesting presentation from A16Z about things like Jolt and Lasso. And that's kind of just the software side of the spectrum. On the hardware side, you have a growing number of companies that basically, some of whom have come out of the Bitcoin mining space, shifting their attention to effectively what they call proof mining, right? And so I think an open question in this space is, what is the right combination of software, which is to say better, more efficient proof systems, hardware, brought upon by companies like these, GPUs, FPGAs, ASICs, that sort of thing, as well as, if you will, systems, which I mean, like how do we parallelize things, that sort of thing, right? And so what is the winning formula? Like how do you combine these properties? I think that's at the moment entirely unclear. But at the same time, we would like to maintain some level of prover decentralization here as well, right? So, and in my mind, I think this is somewhat, more interesting. That's what's happening on the sequencer side potentially as well. So, how do we support, permissionless proving? How do we support diverse hardware setups? And so, how do we incentivize provers like as the core part of this value proposition? So, how do we send the majority of the fee to the prover network, let's say? And again, any number of open issues, like how do you avoid the winner-take-all possibility, right? There's just somebody who has really powerful hardware that they keep in their basement and they basically win every round. Not so great for decentralization, probably not so great for the user as well. And so how do we sort of, in the long term, reduce the cost of proof production, right? How do we make it so that basically there is a reduction of costs on the prover side, and then there's effectively a trickle-down effect where the cost of execution for the end user drops as a result of this as well. So just a couple of points about tokenomics as well. So again, I think there's a lot of temptation to sort of reuse some of the tokenomic models that we've seen in the last 3 to 4 years. Some of these come from ideas around governance, from successful DeFi projects, things of that sort, right? So things like stake-based governance, as well as stake-based protocol participation. And, again, maybe we are sort of jumping the gun here a little bit, right? So it's, for example, easy to criticize proof of work, right? But at the same time, POS-based designs often centralize themselves a lot faster than POW designs, right? So, and we have also seen a number of governance attacks. I think Tornado, in fact, suffered something like that quite recently as well. So yeah, I mean, how to basically design, how to come up with token designs that are not really inheriting some of the problems we've seen in this space in the last several years, I think remains kind of an open question. Also, I don't think we have the best record as a community in terms of like governance for L1s. So Tezos tried an experiment of this sort some years ago. Not sure it was quite as successful, let's say, right? I think we know how to do some forms of governance around DeFi protocols, like for example, Aave, right? Things like that sort, Curve. But when it comes to L1s and L2s, I think there's a lot of complexity that we don't quite understand here. So like what are the outcomes we want here? Well, I kind of alluded to some of these things before, which is we want to have low latency, right? I mean, we want to basically be able to produce soft commits and ultimately hard commits as well. We want to support high throughput. We want to support some level of censorship resistance, probably of the rollup itself, in addition to what's attainable on the L1. And maybe, just maybe, a reduction in MEV, and maybe, a level of network availability that's starting to approach, what we see in the cloud, right, in Web 2 as well. So here's, something else, right? If we are basically want to have, or open to having, let's say, a race to the bottom with respect to transactional fees, right? Like, how do we incentivize progress in this space? How do we, make sure that the best and the brightest, hardware manufacturers come into this and people continue to work on new proof systems and things of that sort, right? And of course, one answer is volume, but maybe there is something else to that as well. Yeah, and I think I talked about this as well, which is like, how do we kind of escape this trap of dominant hardware, right? So that sort of thing. We're not quite there yet, but I think some of these challenges will come up soon. Here's something else, right? So there is, the complexity of these systems when it comes to proof production specifically is such that it's actually easier than we would like to introduce bugs. And there are some, in fact, audit reports that are starting to roll in. So for example, there are projects like Penumbra that had recently had an audit of their circuits. And I think there's quite a lot of sort of complexity to how you not only build these things, but also maintain them over time, right? If you have tens of thousands of lines of code when it comes to circuit production, how do we avoid, let's say, implementation bugs and these kinds of things? Yep. And how do we keep things up if there is like only one way to sort of run it, right? So this has to do with client diversity and execution diversity in one of the slides that I showed to you before when it comes to Ethereum. And so there's been quite a lot of focus, and there are some papers that I mentioned here at the bottom in terms of finding bugs in some of these zero-knowledge systems, not quite as much in zero-knowledge VMs or EVMs for that matter, but there's a strong specific focus, at least in the last 6 months, on finding missing constraints. There are some programming language-based approaches to these kinds of things. But the point here is that, if these things were to be compromised, I think a lot of the value proposition, behind these systems would sort of be compromised as well. So these things are part of our TCB, so we need to do quite a lot to make sure that we protect that. Yeah, so this is essentially kind of what I talked about before. When it comes to privacy, I just wanted to make a couple of points literally when it comes to that. And I think, look, we've seen a number of solutions, things like Cape, Railgun, a few others being proposed proposed on Ethereum's mainnet, and again, those can be run on rollups as well. And in fact, we can make those things easier and more affordable with the help of precompiles, the right precompiles. But I guess the question is like, well, for a rollup that's primarily focused on performance, like, what else do we want? Like, what privacy properties do we actually need to support, and what needs to support natively, if anything, right? So we're probably not going to push these things quite as far as AdStack version 3 does it, with ultimately form of private execution that's sort of reminiscent of what's in this ZXZ paper. But so what should be done? And I think that's not entirely clear at the moment. And I think solutions like Railgun are still sort of experimenting with these things. I think there are some exciting possibilities when it has to do with combining stealth addresses and account abstraction, things of that sort. And there was an interesting presentation about some of these things here yesterday as well. But my sense is it's actually not obvious if much needs to be done at the level of the L2 and whether people are willing to pay for that either. So I'm at the end of my presentation, and I've covered quite a lot of ground, I think. And again, sort of my point here is that this design space is ultimately really quite complex. I think we know some answers, but clearly not all. And these things will probably emerge in the next several years. Happy to take questions if we have a bit of time. Thanks. So the question is about using the EVM. Should we consider other options, that sort of thing? So there's quite a lot of complexity to this question, right? So my sense is that on the one hand, we need to cater to what people want. And again, as I mentioned a few minutes ago, DeFi is a strong driver of these things. If we had another equally strong driver, then I think we would try to cater to that as well. The question is, what's the right mix, right? And do you need to provide sort of some sort of external language interface the way that AdStack now does with WASM, and increasingly many systems are doing with RISC-V, and I think we're sort of moving in that direction eventually as well. So how do you do that without downgrading, let's say, the experience of those building things on Solidity? I think is an interesting question, right? So you kind of want to have Solidity plus, if you will, right? You want to support the EVM, and you want to support that well, and you want to provide all the nice properties and debuggability, but you sort of want to do a bit of extra.
No more time, unfortunately. Ben, thank you so much.